Pre-algebra, lesson 97, two-step problems. So two-step problems are just as they're described. It's actually two problems in one. So we've got this example. If 2x plus 4 equals 6, what is the value of 3x minus 7? So again, we have to be able to identify some things in algebra. We need to be able to tell the difference between an equation and an expression. What we see here is an equation, and I know that because there's an equal sign. Equations can be solved. Expressions can be rewritten. I cannot solve an expression unless I know the value of all the variables in an expression. So for example, 3x minus 7, I can never solve this unless I know the value of x. However, an equation I can solve, right? I can find the value of x in an equation. So that's the two-step process. The step process, or the first step in the process, is to find the value of x. Once I find the value of x, then I can learn the value of 3x minus 7. So let's go ahead and do this problem on paper so we can get a feel for how. Alright, so here we've got our problem. If 2x plus 4 equals 6, what is 3x minus 7? Let me zoom out just a little bit. Too close, a little too close. Alright, so step one, solve the equation. Alright, always solve the equation first. Got to learn what that x is. All right, so I'm going to get the x all by itself. That's my goal. I'm going to do that by using appendix backwards. So I'm going to move the 4 first. I'm going to use the opposite action. Anything I do to one side, I do to the other side for equivalent exchange. That cancels. 2x now equals 6 minus 4, which is 2. And then I'm going to go through all those steps again. There's no more addition or subtraction, so I can move on to multiplication division. I got to get rid of the times 2. The opposite action would be to divide by 2. That cancels. If I do anything to one side, I have to do it to the other. 2 over 2. Well, that just equals 1. So now I know that x equals 1. Great. Step 1 complete. X is equal to 1. Once I know that x is equal to 1, now I use that information by plugging it in to the expression. Once I know the value of x, I can now solve the expression. So we're going to take this x equals 1, put it in parentheses, and we're going to rewrite this problem. So instead of writing 3x minus 7, I'm going to put 3 times parentheses 1 minus 7. And then I can solve that expression now that it's all numbers. Some of you may be thinking, why did I go through the trouble of putting in parentheses? It's just 1 times 3, which is going to be 3. The reason why is because your answer is not always going to be that simple. What if there's a negative? You have to plug everything inside parentheses always. That guarantees that you make no mistakes. 3 times 1 is 3. 3 minus 7. That turns into algebraic addition, so it ends up being 3 plus negative 7, which gives me negative 4. So your final answer on these problems is always going to be the value of the expression, right? Don't stop here. Don't put x equals 1 as your final answer. Your final answer is going to be negative 4, okay? Let's see here. We'll do a harder version. All right, so they've got some examples with fractions. None of the rules change, but I know fractions can be difficult for some of you, so we'll go ahead and do one of those examples, and hopefully that'll help you have some confidence on your homework. All right, so we have if 4/3 x minus 2 equals 4, what is 6x minus 2/5? So first, we're going to start by solving the equation. That's always step number 1. Going to use PEMDAS backwards, so I add 2 to each side using the opposite action, and then equivalent exchange. That cancels, so now I have 4/3 times x equals 6. Now, the fraction. I have to divide by a fraction. Now, some of you may want to use the division symbol, right, 4/3, but if you remember from that lesson, it's better if we multiply by the reciprocal, because dividing by a fraction is the same as multiplying by the reciprocal. So whenever you have a fraction as your coefficient, instead of dividing by 4/3 that way, let's multiply by 3/4. Those cancel, that goes away. If I multiply by 3/4 on the left side, I can multiply by 3/4 on the right side. So 6 now becomes 6 over 1. I can cancel before I multiply. 2 goes into 4 2 times. 2 goes into 6 3 times. 3 times 3 gives me 9. 1 times 2 gives me 2. So x is equal to 9/2. Now I have to take this value and plug it in up here. So again, none of the steps are changing, but we have to remember our rules for fractions because that can be a little difficult. Remember, dividing by fractions is the same as multiplying by the reciprocal or the invert and multiply step. Great. So let's take 9/2, we'll plug it into here. Got 9 halves, and then I'll copy down the rest. Where did my black pen go? There it is. So I've got 6 times 9 halves minus 2 fifths. Great. All I have to do is just multiply the fraction by the whole number again, place the whole number over 1, cross cancel if possible. 2 goes into 2 one time, 2 goes into 6 3 times. Now I have 3 times 9. 3 times 9 is 27 over 1. Now I have to do 27 over 1 minus 2 fifths. There's an obvious denominator problem here. So let's see here. What is... wait a second. Nope, that's right. You know what? Maybe I won't multiply 27 over 1. I'll just use some mixed numbers. That's much easier. Okay, I was about to try to multiply 27 times 5. That's a terrible idea. I'm going to use regrouping. So let's write this vertically. I have 27 minus 2 fifths. Okay, I'm going to regroup 27. That's going to become 26. And I'm going to take that 1 that I pulled out, and I'm going to turn that into 5 fifths. And now I can subtract 5 fifths minus 2 fifths gives me 3 fifths. 26 minus nothing is 26. My final answer, 26 and 3 fifths. All right, so remember when we're adding and subtracting fractions, let's stick with mixed numbers. If we're multiplying and dividing, that's when we want to use improper fractions. All right, that's all I've got for this lesson. If you have any questions, let me know on the school website, and I will see you in class.